Okay, so welcome to our cyber training webinar. And today, let's welcome Dr. Zhenhua He from Texas A&M High Performance Research Computing Center. And today he's going to present computing on composable resources and to introduce NSF ACES. So Dr. Zhenhua He is an associate research scientist at Texas A&M High Performance Research Computing, and his background is in science, particularly in geomedical modeling and computer science. And at the Texas A&M High Performance Computing Center, and his main responsibility is to benchmark the novel technologies and hardware with AI and machine learning models. And he also conducts many training sessions of AI and machine learning and novel technologies to nationwide researchers. So let's give our warmest welcome to Dr. Zhenhua He. And thank you for your time. Zhenhua,
Thank you.
yeah.
Thank you for your introduction. Hello, everyone. My name is Zhenhua He, and today I will give you a brief introduction about the computing on composable resources, ACES computing cluster. And actually, at Texas A&M High Performance Research Computing, we operate 5 different computing clusters. The first one is called Grace. It's the largest computing cluster in our center, and it has about 1,000 nodes, and also a few. And I think it also has about 100 of GPU nodes as well. So it's very it's our flagship cluster before, and I think once it was on the top 500 in the world. I think that was some years ago. And now we also operate 4 other computing clusters as well: Widal, Virtual Data Library, Launch, Faster, and ACES. Today, we will mainly focus on the last 2, Faster and ACES, because they are both composable, and because in nowadays, and people want to know about the composability of the HPC computing resources. If you are interested in our computing resources at Texas A&M High Performance Research Computing, you are welcome to check out this page and to look at all our computing clusters. Don't worry about this. If you don't have the link, I think I will send the slides to Dr. Zhang after this webinar, and you can, I think she can distribute this presentation slides to you guys, and then you can explore all sorts of things after this. So don't worry about it if you cannot get the link. This is the outline for today's webinar. First, what is composability? Why we want composability? And also, I will give a brief overview about ACES and its available accelerators for you to use. This is mainly for HPC experts, like you are interested in composability accelerators to speed up your scientific workflows, and or if you work on AI ML. But also we have some contents for new users as well, for new HPC users as well. For example, how to access our clusters, what is your usage policies, what is our portal or cluster basics, how can I do this, right? And I want you to understand some of the software infrastructure, for example, how we can manage the softwares, the different versions, so many versions of softwares on HPC cluster, and also batch computing, like we have many jobs from different users, how we manage them, and in different queues like that. Okay, what is composability? So nowadays, most of the HPC clusters are traditional or common. They are actually in a very static manner, meaning like for each of their HPC compute node, they have fixed, for example, CPU cores, memory, disk, or GPU accelerators. They are very hard to move around to get to compose a different node. However, for our faster and ACES computing composable cluster, it's a different situation. We use a technology called liquid composable technology, and it's composable fabrics that it can like rearrange the computer resources and compose different types of compute nodes. So it's very dynamic and also very flexible for users to use. For example, hey, I want to use these many cores or this much of memory on this node. That's okay, and we can use the liquid composable fabric to compose that node for you, for your needs. So this is very dynamic and flexible. So if you have any questions, you can send the question to the chat, or even you can stop me and ask MU yourself and speak out. Okay, this is another nice graph for composability. You can see this is a traditional server, and you have the GPUs, memory, or but they are very static. You cannot actually do much to these nodes. For example, this node, it only has 4 GPUs, but you cannot like move these GPUs around, do something else. So it's very static. But for this one, the computing resources or composable resources are in different pools. For example, the server pools like CPUs and the CPU cores, or the accelerator pool. We have, for example, the GPUs, FPGAs, or even you have some like memory. You can also, these are in different pools. And then we can use the liquid composable fabric to pull these resources from these pools and then compose different nodes. For example, you can see here, we can even compose a like 14 GPU node. That's a great advantage because some of the applications, it's hard to go across nodes, or even go across nodes. The bandwidth for the across the nodes is not that good. So if we can compose these nodes through the composable fabric, it will be much easier for the user to run their workflows. Next, I will give an overview of the ACES computing cluster. So actually at HPRC, we have 2 composable clusters. One is the first one is called FASTER. It's first large-scale composable CPU, GPU system. On the ACES, it's a little bit more complex because we have mixed resource. We have a rich variety of accelerators. I will show a little bit later. FASTER, we mainly use NVIDIA A100 GPUs. So let's a brief introduction about the Access Computing Cluster. It's funded by National Science Foundation. ACES stands for Accelerating Computing for Emerging Sciences. This is the project mission. It's work as a testbed, and it offers an accelerator testbed for different numerical simulations and AI ML workloads. And the project team also provides consulting, technical guidance, and training to nationwide researchers. So if you have any questions, you can actually, we provide workshop tutorials and short courses, or even webinar like today, to different researchers, and we can help researchers to get on our ACES computing cluster to speed up their workflows. And also we collaborate with other supercomputing centers on computational and data-enabled research. For example, we benchmark different the technologies, for example, the composable technologies and the performance of the different accelerators, and then we publish as well. So this is another thing. This is where the ACES computing cluster. This is actually our West Campus data center. And there are also some pictures at the front and back of the ACES computing cluster. You can see the racks and also the networking of this computing cluster. So just give you some intuitive look about the ACES computing cluster. And also this is the configuration of ACES computing cluster. You can see it's very complicated and much more complex than the faster cluster. And you can see we use the composable PCIe Gen 4, Gen 5 fabrics, and it compose the Intel data center GPU, NVIDIA GPUs, Intel FPGAs, BeadyWare, and also different types of accelerators, and then make different nodes. So, and also we have some other accelerators as well, but they are not composed. They are called graph core intelligence processing units. It's like a GPU, but it's a different design architecture. So, but they are not composable. So we put them as standalone nodes in the ACES computing cluster. We also have management nodes, data transfer nodes, logging nodes on the ACES as well. They are connected by NDR InfiniBand. Okay, this is a little bit about the system description. We have about like 110 Sapphire Rapids nodes, Ice Lake nodes. These are the nodes that use the composable fabric like PCIe Gen 4 fabric, PCIe Gen 60 on the PCIe Gen 5 fabric. We have about 2.5 petabyte usable storage as well on ACES. So these are the ACES computing cluster accelerators. So we have 32 graphical IPUs. We have a few Intel and BeadyWare FPGAs, and 2 Next Silicon coprocessor, 8 NEC vector engines, and also we have some Intel Optane SSDs that can be addressable as memory with the MemVerge memory machine. Means like if you have some application that use a lot of memory, a large memory, for example, like greater than, for example, 500 gigabytes, you want to use like a few terabytes, we can use this technology to help you get more memory. And also we have about 30 NVIDIA H100 GPUs for NVIDIA A30 GPUs as well. We have about 120 Intel data center GPU Max 1100. So all sorts of accelerators, and if you are interested in using any of them, and you are welcome to test your applications on this computing platform. I will skip this system software stack. I think it's not so. So just a brief summary that ACES and Faster are composable computing platforms, and it has a lot of ACES. It has various types of accelerators for users to use, and for their numerical simulations or AI ML workloads. So this is basically what we have go through by now. So next is, hey, I know your ACES cluster now. How can I access your ACES cluster? Yes, we have ACES Open On Demand portal for users to use. For example, here, if you go to our webpage, or you can just do this URL, portal-aces.hprc.tmu.edu. You can get to the ACES Open On Demand portal. And And here you will open the portal and you can see a few tags here. And then I will introduce these tags, tabs a little later. And then if you click on ACES shell access, you will open up the terminal in your web browser to run some commands, right? So this will be very like your Mac terminal or your mobile term or the SSH in your Windows system, or the terminal in your Mac OS or our computing cluster, we use Slurm to manage the resources. So you will have to write some job scripts to submit your job to our cluster. So this is one example job script. You can see you can give your job a name, for example, my job, and your time you want it to run on the cluster. This is about 2 days, or you can just specify 1 hour, how many number of nodes you want, and how many cores or tasks on your per node. For example, this one says, hey, I want 2 tasks per node, but for per task, I want to use 96 CPUs. Memory, the usable memory on each, I think it's on each ACES computing node is about 488 gigabyte. So if you want more, as I said, we can use the large memory node, or you can use the use the opt-in SSDs to do some to get more memory as well. This one, it asks for GPU. You can specify the dash partition to be GPU, and grass means like when you request like GPUs, you can use this grass parameter, and you specify, hey, I want to use GPU. I want to use the H100. I want to use 2 H100. So this is just an example. And also you can specify the directory to your output file and error files. Yeah. And also there are some other commands here as well. I will introduce the module a little later. So current status of composability. It's currently handled by our system administrators. So it's not users controlled. So it's you of course if you want to test something on our composable node, you can contact us. This is the email, and to request a given composable configuration for our cluster. For example, hey, I want a 16 GPU on one node, and can I get this node? And I want to run my workload on a 16 GPU node. Our system admin will rearrange the resources and try our best to accommodate your request. And so after that, you can simplify the relevant resources in your Slurm job file, like the one before. Hey, I can specify 16 GPUs now. It's not just 2, right? So it'll be the work in progress is making Slurm and Liquid handled automatically. Like you submit a job, and then you request the number of GPUs, and it will compose a node automatically. But currently, it's not workable. But we are in the progress. So okay, and also IPU and NEC vector engine cannot be composed because of some software incompatibility from the vendors. So that's one thing. This is some accelerator summary. If you're interested, you can read this. I will send these slides to Dr. Zhang after this webinar. As I said, ACES has a lot of accelerators, NVIDIA GPUs and other accelerators as well. And we have NVIDIA A30s. It supports less intensive workloads like inference. H100 GPUs are more powerful. It can do AI ML training or inference or other compute intensive numerical simulations as well. So you can just specify this, the GPU type and the numbers here. And also we have Intel data center GPUs as well. We have a lot. We have about like 120. You can specify in your Slurm job in the partition. You can specify PVC because this PVC is the acronym for this GPU. So you can just specify PVC and then specify the number you want to use as well. Intelligence processing units are another type of accelerators on ACES. The design of IPU, the architecture is very different from CPUs and GPUs. So it is good for some fine-grained parallelism workloads. So maybe for example, your application may be good for IPUs and it can be gain a lot of performance gain, get a lot of performance speed up on IPUs as well. So if you have any like workloads you want to test on ACES, you can let us know and then we can help you as well. Yeah, and some of the graphical IPU documentation, how to access the graphical IPUs, we have, you can just, because it's not composable, so you can just, for example, once you log into ACES login node, and you can do SSH Poplar 1 or Poplar 2 from ACES, you will get on the IPU system and then run your workloads there. So we have a lot of knowledge base page for IPUs and also for our GPUs. We also have a knowledge base for this and also examples. So don't worry if you feel like, hey, I don't know how to run workloads on your computing cluster. We have the knowledge base and user guides to help you get started. We also have NEC vector engines. I will not give deep dive about this. I just want to show some specifications of them here, and you can read it later as well because our time is very limited, and I just want to give you a brief overview about this. All sorts of accelerators on ACES. These are the composing memory that you can get a large memory node as well. Okay, specifically because for ACES, one of our focus is on AI ML. So we have trying to help our AI ML researchers on ACES, and we install the Hugging Face Hub for the for their models and data sets, and also we have GitFS, the large file storage, so they can download the checkpoints, the large checkpoints, or the data sets onto our computing cluster, and then run their models as well. So some Hugging Face libraries we tested on our computing cluster. So this is basically about our ACES computing cluster and some of the. Next, I want to introduce about the documentation and the training about our ACES computing cluster. So as I said, we have knowledge base pages for 5 clusters we have at HPRC. This one is for ACES, for example. You can see the hardware, key policies, how you can access the cluster, computing environment, and all these different things here, the different accelerators. We have included different examples, so you can directly run some examples on different accelerators, and then you can think about your own application, how to migrate or modify your own application to run it on different accelerators as well. This is the link to the knowledge base page. And actually, we have posted a lot of our training videos on YouTube. We have I think more than 100 videos there. I think maybe much larger than this number, 107. You are welcome to subscribe to our YouTube channel, and and then to learn from like ACES getting started or AIML, or we also even have some other um, videos as well to help you. For example, introduction to how Linux, if you are a new user about Linux, um, as well. And also we have accelerator training for Intel data center GPUs. It will be happening on March the 4th. For the intelligence processing units, it will be on March the 18th. So stay tuned. So how can we get started on the ACES cluster? So first thing first, we have some usage policies for you, and we want to be a good computing citizen, right? So first, it's illegal to share computer passwords and accounts, so don't share your passwords and accounts with your friends. Clusters must not be used in any manner that violates the United States export control laws and regulations, ER or ITR, like this. So we don't want you to violate. Otherwise, your account may be suspended, and so that's very important. And you want to abide by the license restrictions when you want to use some commercial software. You can, of course, if you want to install some licensed software, you can also contact us and we can help you from there. So how can we use this clusters? Actually, these computing clusters has been are offered through NSF Access Program and NAIR Pilot Program. So these are two programs, and you can request allocations on these two. So you first thing is to create an account on Access or NAIR Pilot, and then you can select opportunity, and also you can request allocations. We support 3 different types of allocations, ACES and faster, and then you receive credits from NSF Access or NAIR Pilot, and then you can exchange credits to ACES or faster. So this is a kind of a flow for you to get on our clusters. So this is the link for you to apply application for ACES on Access. So if how many of you guys have had an Access account? Give me a thumbs up if you have an Access account, or a thumbs down if you don't. You guys never heard about NSF Access, right? Okay, I saw thumbs downs. Yes. Yeah, if you want to use ACES or faster, you will have to have an access ID and then get on this. If Dr. John wants to use like ACES in the cluster, I think you guys can set up to apply for ACES access ID and then apply for an allocation for your course or something like this. But also Grace, as I said at the beginning, Grace is specific for Texas A&M users. So as long as you have a net ID, we can let you get on the Grace cluster. So don't worry about that. And for access allocations, there are different opportunities, and we support 3 types of allocations here. The first one is called Explore. The second is Discover and Accelerate. The Explore allocation is relatively small, but it's already good for a small classes like with several tens of students. It just require an overview of your project or class. But for Discover, you will need to provide about a 1-page proposal. For Accelerate, you will need to provide about a 3-page proposal to get the allocation. So, okay. Once you get on this computing clusters, for example, if you get on the Grace computing cluster, or you have applied for access IDs and then you get on the ACES computing cluster, how can you do your computing on these clusters? So first thing first, you have your computer, right? So you have your different SSH program. For example, on your Windows, you may have PuTTY SSH or mobile Xterm. You can use that to connect to our computing cluster. Or you can have another option to use our portal to connect to our computing cluster. The first place you will be landing on is a login node. And on this login node, you can do some lightweight stuff. For example, you just do some coding or do some lightweight job running on that. And then after that, you feel, hey, my code is ready for running on more computing resources. And then you can use the job file, Slurm job file to send it to the compute nodes, use more cores, more GPUs, and that will be through Slurm. So, but now no SSH to ACES at this time, but it's okay on faster. So, this is our web page. Under the portal menu, you can find ACES portal access. So after that, you will be directed to a page called access, and then you will need to type your access ID and your password. And after that, you will be directed to ACES Open On Demand portal. So after you get on our ACES Open On Demand portal, you will see this interface. For example, files, jobs, clusters, interactive apps, and etc. So, for example, files, you can, for example, you have some script here. You can open it. You can edit from here as well. If you're not familiar, like the Linux, you want to use you just wanted to open it in a browser, and then you can directly edit. That's also okay in our file editor. If you are familiar with the editors in Linux, like a Vim editor, you can also use the Vim editor in the terminal as well. So, but this is more flexible and easy to use and friendly to some new HPC users. And the next, jobs, you can check the status of jobs from here. For example, you can, for example, you submitted some jobs, you can see it pending, running, complete, or some like your job status here. Also, we have some composer for you to compose a job script for you by, like, you can just fill in a form, and then the composer will help you to write a job script. So you don't have to memorize any directives in the Slurm. So we just want to make our cluster friendly to new HPC users. So this is the terminal. So give a quick throw, I think. Okay, on login node, as I said, when you use your computer to connect to our computing cluster, the first place you land on is a login node, but we have some strict rules on the login node. No processes longer 1 hour. Sessions idle for 1 hour will be killed. Do not use more than 8 cores. Do not use sudo, like because you are not a root user or administrators, so do not use sudo. And why we put such rules on login node, because it's shared among the users, so we don't want your working program affect other people's job. And also we have interactive apps. For example, we have a Jupyter Notebook, Jupyter Lab, RStudio. If you use like Python, R, you can open interactive apps from here. And also you can check the status of your job here as well. Some affinity groups. If you are interested in knowing more about the ACES and R, you can join our affinity groups as well. So next, if you get on our clusters, you will get some resource allocation. For example, you will get some file limit, and for example, on your home directory, you will have 10,000 file limits. For your Scratch, you will have 250,000 file limits. However, eventually you will almost reach the file limits, but you can always request an increase in your quota. So, for example, hey, I want to request an increase of my limit. For example, space limit. For example, just 1 TB. I want maybe 5 TB. You can request an increase from here through the dashboard. Any questions so far? I know I have gone through a lot. I just want to cover as much as possible so you guys have a general overview about our cluster. Our clusters are all very similar. Once you understand ACES, you understand Grace, you understand faster, so don't worry about other clusters as well. This is some utilities built by our system admins and for the easy use of our users. For example, if you want to check the availability of CPUs, GPUs, or some shared environments, you can use these tools as well. Quotas, yeah, I just briefly go over. Once you get our computing cluster, and you will have 2 directories. One is called home, the other is called Scratch. Scratch is larger, so we hope you can put out most of your files and workloads on the Scratch, because it has default space is 1 TB. The file limits is 250,000. So, but the home is much smaller, but it's do some small job processing, that's okay. But for most of the job, your jobs, we encourage you to use the Scratch, so you don't hit the quota limits easily. So, and also you can check your. Okay, I see a question in the chat. How can I determine the running time and the amount of GPU nodes when I submit my job file to run my model in HPRC? Okay, great question. Like the running time, you can actually do some small testing on the logging node. For example, hey, for example, your job have many steps. You can do some small testing on the logging node, and then you can see, hey, 1 hour may finish like this many steps, and then by estimating, I think maybe like 10 hours or 1 day is good enough for my job. And then you can submit a wall clock time in your job file, like for example, 1 day. GPU nodes, it depends on, for example, if you have a very large model, you may want to, like you want to distribute your model across GPUs. That may need some work for you to like do some distribution of your workloads, and then after you test that, like you want how fast your model be running. You will need to do some small testing on the logging node as well. We have some GPU logging nodes with some GPUs as well. So it could be, it's some like a trial and error and a testing process to determine how long you need for your job, because it's really varies depending on different jobs and users. So I hope I answer your question. Then I will move on. Service units, yeah. For basic users like students, we usually give you like 20,000 SUs, and then you will be spending these service units when you submit jobs. 1 SU is about 1 core hour on a CPU. For example, you have like 20,000 SUs, you can run 20,000 core hours on 1 core, on 1 CPU. But if you want to like do parallel computing. For example, I want to use 100 CPU cores at a time, and then the hour will be like 20,000 divided by 100 cores, right? That will be the hours you can run your job. Yeah, so the service units is limited. So, and also you can use my project command to check your balance. The GPUs are more expensive, so we charge more if you use our GPUs. For example, NVIDIA H100 GPUs is very expensive, and also it's very computing powerful. So if we charge like 120 SUs per hour for one H100 GPUs, if you want to use GPUs, maybe you will need to ask your professor or advisor to request more allocations for you as well. So other accelerators are listed here as well. Next is about the software infrastructure. So we manage many different types of softwares on our ACES computing cluster. We have about like 2,400 software modules. And so you can imagine that's a large number, right? Computing cluster. But if actually our system administrators are responsible for installing the softwares as modules on our cluster. But if you want to install some softwares, you can contact us as well. Or if you have experience in virtual environment, you can also install some of the softwares or libraries into your virtual environment as well. Yeah, for commercial software, you will have to have a license, and you can contact us as well. So we use L mode to manage the softwares on ACES. We use most of the commands beginning with the module word. So you can see, for example, if you guys know about PyTorch, for example, hey, I want to load the software PyTorch built with the CUDA 1211, and you can use a module load this software. However, it will give you an error because you are not complete yet. This software depends on other software as well. For example, these are called tool chains then. And then you will need to load this dependent tool chains first, and then load this software. So this is called hierarchical module system. So I will not get into detail about this, but if you needed to learn more about this, we have this knowledge base page. And also I will give you some examples here as well. So module avail, it will give you all the available modules on our cluster. That's a lot. You can imagine like 2,000 something modules. But if you know your software, you can just module spider the name of your software. And if we have that software, it will give you a list of the software. For example, I want to search Python on the ACES computing cluster. For example, you can do module spider Python. You can get a list of all the versions of Pythons on our cluster. And then you can choose any version of these Pythons, and then you can load it to your computing cluster. For example, here, you can use module load command. And also, you can use module list to see what modules you have in your environment as well. For example, here, module list, we can see a GCC core 13.2.0 has been loaded into the environment. Module purge is used to unload all modules. For example, you are working, after you finish one project, you want to move on to another project. You don't want the software modules affecting your next workflow, right? So you want to do a module purge, and then it will give you a clean environment for the next project. So this is a good practice for you to do. There are some hands-on exercises. I think we don't have time to work on this. You can, we will distribute the presentation slides to you so you can play with this exercise later. this is also about Python and virtual environment. We know sometimes I worked with Dr. John's group before. I know they use virtual environment. And for example, you need some packages into a working environment. You can install them into a virtual environment as well. So for example, SciPy, NumPy, scikit-learn. Yeah. This is an example about how to create a Python virtual environment. For example, you first load the Python and then you use the create a virtual environment and you activate your virtual environment and then you install the packages into the virtual environment that you want to use. So this is again the Slurm job file. We have a lot of example files for you to use um, in the knowledge base. And so even for CPU jobs example, GPU job example, you can grab one of these and then customize it for your own job. After you finish your job script file, you can use sbatch command to submit it to our cluster. So it will be running. And also you can use sq command to check the status of your job. For example, here its state is running, or it will tell you complete like that. So this is a complete example. You can run this example. We prepared for you guys, and you guys can run this example after this webinar. So you can check how the status changed. For example, pending, running, complete, like this. Oh, we're running out of time. So okay. Yes, I think we can stop here. We still have some other content here, but I think we can distribute this presentation slides to you guys, and then you can see, you can read more by yourself. Okay, Dr. Zhang, do you want me to stop here?
Thank you so much,
Okay.
Zhenhua, for the excellent lecture. It's really useful. I teach programming and WebGS class at Texas A&M, and I believe these computing resources will benefit all our students, but not only from Texas A&M. So I think we probably have only 2 minutes for one question. Please let me know if you have any.
Okay.
So other training session you mentioned earlier going to be free.
Yeah, yes. The training sessions offered by Texas A&M High Performance Computing are completely free. But we request you to register for these training sessions on our website. I want to show you guys here. Okay, there's something here. And if you go to Tamil HPRC, I think you guys can still see my screen, right? So courses here, for example, we offer a lot of training sessions here, but we want you to register. For example, if you are interested in knowing about Python programmers, you can just review details and then you can register here. So they are completely free, and but there are some requirements. For example, if you wanted to run it on our cluster, you will have to have at least a Tamilnet ID or Access ID. So we will send you instructions about how to apply for them. Yes.
Thank you. Thank you
You're
so
welcome.
much.
Yes, thank you very much.
Thank
You're
you.
welcome.
I think we are running out of time. Let's give our warmest thanks to Dr. He. And thank you so much for your excellent lecture.
Thank you.
Have a great afternoon.
You too. Bye.
Bye-bye. Thank you, everyone.
Thank you. Bye.
Bye-bye.